So like, I'm gonna do this for like the monolith game object things. And I'm out of like things to figure out. So I'm gonna put it all together. Whoop-de-doo. So each of the stupid monolith ID things, whatever, be like this. Then I need these. All these sort arrays to use a linked list where it like rotates the list or whatever. So each item holds the item before it, which holds it, which holds the next. Which doesn't, yeah. So I gotta figure out how to like set that up again. And like since like the ID items in monolith array okay, so like if this sort of array it holds the thing before the thing that holds it. Oh, it stopped working. How surprising. Really. Alright. So like if y is like the thing I'm accessing, I make y hold x, they need to access x to get to y. But not really. Because I really want to hold x. So we can access what it holds, which is y. So if I do that, then I can insert something between the two nodes without having to like loop. Because I have the last node and the current node. The last node which holds the current node. I can get the next node to like insert one or remove one. So yeah, whatever. But if this does that, the sort of list, I think that means the monolith list needs to also do that. Because this is 3. There's 3 here. It makes sense to like keep them in sync. Which means like to access this one, I gotta like dereference it. If I don't, well, I also need I want the insert time for this one too. So I want the same insert time behavior. So then it's basically just whatever this thing is assigned to here, then access it the same way, I think. So I guess I'll find out, or not. I'm not gonna waste time as a chatbot because it doesn't know. So I'm gonna set that up. I want to like find the loop macros. Replace them with includes, file includes. Then I can like attach a time scheduler. And then I can like load up with data and let it rip and see how fast it is. So yeah. Here's some exciting math stuff. Well, I don't mean that sarcastically. So I'm gonna try to like get something in place. Then yeah. Did I even switch the screen? I don't know, whatever. I had to get this running. I'm tired of this crap. C language is garbage. The browser is garbage. Alright, the browser is like so much worse than JonsScript. I mean, C language. That's not even funny. It's like in the standard for JavaScript. So like
star exports that are not explicitly requested anywhere.
try it again. It's like JavaScript in the standard. Standard is terrible.
Get module namespace never throws. Instead, unresolvable names are simply excluded from the namespace at this point. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere.
Like,
they will lead to a real linking error later.
so they're like, don't worry about throwing errors. Just later on, the linker, that'll catch it. That'll catch ears. Like, holy fuck. This standard is a fucking joke. The whole thing's a joke. Like, the security of your fucking device relies on JavaScript. Because, like, that's how the client device communicates. Unless it's like fucking like post message or something. I think that's JavaScript too. Just like, what the hell? And there's like a bunch of spots where they're like, oh, throw a warning for the step before if there's an error. And people like, clearly, it doesn't catch it. There's no one ever catches it when it gets thrown. And it continues to run, exposes the address space. This stuff is ridiculous. Async loop. The heck? Oh my god. Safari's out of date. What is Whoop? Oh, I can't believe it. Tor browser is more up to date than Safari. What the hell? Alright, so like, what does this mean? Alright, is that an example? Also have Siri rated. For text-to-speech.
Skip to content open sidebar chat GP.
Everything sucks.
What does this mean? Get module namespace never throws. Instead, unresolvable names are simply excluded from the namespace at this point. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere. And is that an example of good programming practices? Why or why not?
And in the case of like
And in the case of like a large public program, would handling things in such way be considered safe and or secure if compared to dealing with the issue then and there? Handling. The statement you're referring to is talking about how the function getModule namespace handles unresolved symbols or names in a module system. Here's a breakdown of what it's trying to say. Breakdown of the statement 1. GetModule namespace never throws. This means that the function does not raise errors or exceptions when it encounters an issue, like an unresolved name. It silently handles it instead. 2. Instead, unresolvable names are simply excluded from the namespace at this point. If the function cannot resolve a name, that is, it doesn't find the corresponding definition or symbol, it removes that name from the namespace, essentially ignoring it for the time being. 3. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere. If you later try to use one of those unresolved names in your program, you'll get a linking error, that is, an actual runtime error, but only if the unresolved name was important and required by the program. The exception is when there are ambiguous star exports, that is, wildcards like in some languages, or export from, which are not directly used in the code but might still be included for some reason without causing immediate failure. Is this good programming practice? Not necessarily. Here are the pros and cons. Pros 1. Graceful degradation. The fact that get module namespace doesn't throw an error immediately allows the program to continue running even when some parts of it are unresolved. This can be useful in environments where you want to avoid halting execution unnecessarily, especially if the unresolved symbols are non-critical. 2. Delayed failure. For better debugging, by deferring the error to a later time, when linking occurs, it might give developers more context about where and why the failure happens. This could help isolate the cause of the issue more effectively. Cons 1. Harder to detect errors early. The major drawback of this approach is that the program doesn't immediately report problems. If you have unresolved names that should have been resolved, waiting until later to throw an error could lead to harder to debug issues. You only find out the problem once it becomes critical during linking or execution, which can make troubleshooting more difficult. 2. Silent failures. Excluding unresolved names from the namespace and silently moving on could lead to missed dependencies or runtime errors that are harder to detect. In large or complex programs, this could cause failures that aren't immediately obvious, leading to unreliable or inconsistent behavior. 3. Security risk. In a large public program, especially one with many third-party modules, this approach can be risky. Unresolved names that are silently ignored could be indicative of missing dependencies or modules that might lead to inconsistent behavior. In security-sensitive applications, such failures could lead to vulnerabilities that could be exploited by an attacker. For example, a missing function could be substituted with an incorrect or malicious version later in the linking phase.
Sometimes it's like, is this on purpose? Or is this like just lack of like not giving a fuck?
Comparing with immediate handling, throwing errors earlier. 1. Handling issues immediately. Throwing an error when an unresolved symbol is found might be more secure because it prevents the program from proceeding with an incomplete or corrupted state. It would ensure that all dependencies are resolved at the start and you know exactly where things go wrong. 2. More predictable behavior. By catching errors earlier, the developer can fix issues when they first appear, which is usually more efficient in the long run. 3. Security. Immediate failure or detection of missing dependencies means that you are less likely to run into a situation where unresolved symbols create unexpected behavior in the runtime, which could introduce vulnerabilities. Conclusion. Is this approach safe and secure for large public programs? In large, public programs, handling unresolved names immediately, for example, throwing an error or some clear indication that something is wrong, is generally safer and more secure. It minimizes the risk of delayed failures, which could lead to hard-to-debug issues or, worse, security vulnerabilities.
It's like the one thing that HTML, CSS, JavaScript, just all of them.
While ignoring the issue and allowing it to surface later could work in some cases, it requires a careful balance. In a security-conscious environment, it's usually safer to catch issues earlier, especially with modules and dependencies that could affect how the program behaves and interacts with users.
Then Chrome's like, oh, we're so secure, security.
In a security-conscious environment,
Are these people conscious of like security? No.
a good compromise. A good middle ground might be to log unresolved names or warnings at an early stage, but still allow for the program to proceed in a controlled manner. This way, you get the benefit of early feedback while still maintaining the flexibility to handle non-critical issues gracefully.
I think this is intentional, and it's for this reason exactly.
For example, a missing function could be substituted with an incorrect or malicious version later in the linking phase.
That's the only reason I could see someone being like, let's just overlook it, and then the linker will catch it. Yeah. Just put it off till then. Then linker will get it. Yeah. Just like, let the linker get it. Just leave it. Linker will get it. It'll throw a real error. Don't throw an error here. The linker will get it and throw an error there. Yeah. Seems intentional.
For example, a missing function could be substituted with an incorrect or malicious version later in the linking phase.
If you hit a spot and it's like, this could fuck it up, you don't go, oh, let's wait and see how fucked it gets. Or like, well, the linker should handle it, so let it fuck up there. Like, what the fuck is that? It's in the standard. Holy fuck. It says 122 terabytes. Oh, come on, show it again. Alright, wherever it said it. Alright, so like, people have been hacking and saving like invisible text to like the calendar. Unlike, like this is like, it's kind of funny, but it's not. The modern operating system, web browser, it's ridiculous.
A little too creative, and it's kind of freaking me out. We're talking about a couple things we're seeing on GitHub today. In particular, it kind of starts with this weird obfuscation technique people are seeing, where in packages uploaded to GitHub that are fed in as NPM packages and VS Code Marketplace packages, we're seeing this little pattern of code here where malware authors are hiding malicious JavaScript inside of this string. Literally, there could be thousands of characters in here, and they're obfuscating it by packing it in as this Unicode variation selector. So there's a bunch of different characters in the Unicode spec that actually don't render as anything. If you're to open a file like this in VS Code, or I think even Vim in some cases, this piece of code would not render as anything. I think even in a GitHub commit, you wouldn't see any code inside this block. And so this loader here literally just runs, it takes a string and it takes it and removes the Unicode like top end of the string and then runs it into an eval, and that runs the code arbitrarily, right? So it's basically giving them arbitrary code execution from a string that your browser or your visualizer.
If you mix like left to right and right to left characters, like what's the it's not Jewish. What did the Jews write? I don't mean like the Jews, I mean like the Jewish language. Oh, Hebrew. It's like Hebrew and Arabic. There's like right to left text, The people are hacking. I don't know, they don't know typography. I think there's ways you could like make it collapse so it doesn't be turned to like one big block where it's like really obvious. That might not be Unicode though. That might just be in the browser. I don't know, whatever. Hackers aren't the smartest.
Text editors can't even render, which is crazy enough to begin with, right? But then I was reading this article and it hinted towards this other article that hints at the same threat actor. They're calling this Glassworm, and I think Ars Technica kind of missed the boat on what's actually going on here. The crazy part is how the C2 is working here. So you guys remember Shai Hulud, right? Shai Hulud was this bug that was infecting maintainers of NPM packages so that when they committed code to NPM, it would install like a Shai Hulud backdoor into the package. People would download that package and it would self-replicate, right? There's another one coming down that is attacking the VS Code extension marketplace, and the way that it propagates is even worse, okay? So this is the company that has an engine for detecting this stuff. Obviously, if you want to see them, go check it out. Not a sponsor, just part of the video. So they're using kind of the same technique, and I want to highlight kind of the hilarity of this screenshot here. See this massive gap between lines 2 and 7? Yeah, dude, it's the size of the fucking Sahara Desert. If you don't see this, I don't know really what to tell you. You know, some text renderers may see this differently, but like when you look at this code, you're like, if you don't think something suspicious is going on here, I'm not really sure what to tell you. That being said, you know, maybe you don't read all the code in your packages. It's very common for people to not read all their code. Unfortunately, the nature of like the Python, Node, and OpenVSX like marketplace ecosystem is that you don't read like over half the code you use, which is like kind of terrifying. A lot of it is dependent on trust. You have to kind of just like look at the number of stars the packages has and hope that like the stars is indicative of trust, right? But in any case, they have these packages that are coming down with these payloads that are obfuscated via this Unicode technique, right? We're using Unicode characters that don't render as anything and then de-encrypting or de-encoding the Unicode to run the malware, right? But this is where it gets crazy. I don't know a ton about crypto. I do know that like Bitcoin has been crashing or something, but they use the Solana blockchain for C2. Like I didn't know you could communicate over crypto. I didn't realize you could like send messages. So what they do is inside of the payload that gets decoded, they are using attacker wallet strings to send and receive messages via Solana. So it's like, you know, they pay a market fee of less than a cent. And when they do this, they get data from the transaction that contains links to their C2, to their like payload upload server where they send all the encrypted data. Now, why is this brilliant and terrifying? I agree. First of all, the transaction is immutable, so you can't be deleted. Like it can't go away because the nature of a blockchain is literally that the blockchain is ever growing. It is globally distributed and is immutable. You can't change it. Also, yeah, by definition, there is no KYC. There is no know your customer on these wallets. So by design, the Solana transactions are anonymous, and then it's legitimate. Like this is part of the Solana blockchain. So if your network allows Solana transactions, which most of them do, no real way to get around this, okay? And yeah, it's very cheap. It costs them less than a cent, like fractions of a cent to execute this transaction, okay? So in that link, they contained their C2 payload, where they then told the C2, the malware on the other end, to encrypt the data with AES-256 CBC. Now, obviously, this is symmetric encryption, right? So if you were locally on that computer watching this occur, you could see the HTTP response headers, and you could see the 256 encryption key. Not super impressive there. But then, after all of this runs, they use a Google Calendar link to turn your computer into a proxy for this network, right? So they use a Google Calendar invite to download this zombie payload. I don't know what zombie stands for. I guess it's like a zombie botnet. And then they turn your computer into a proxy for their criminal infrastructure network. They literally are like, all right, cool. So we've downloaded all your stuff. We've done the transaction off the Solana network. And then they use all of this to turn you into a proxy SOC server so they can bounce in between your computer around the network.
And then like JavaScript standard, it'd be like
get module namespace never throws. Instead, unresolvable names are simply excluded from the namespace at this point. They will lead to a real linking error later unless they are all ambiguous star exports that are not explicitly requested anywhere.
It's kind of like a real boy, like Pinocchio. It's like, I'm a real boy. It's like, I'm a real heir. Until then, it's just like a lurking bug exploitation. Just something that's not an error. It's not a real error. What is it then? This is ridiculous. It's pathetic. I'm so glad my JavaScript engine. Oh, I got a burp. Way better than this shit. I'm gonna have to, like, it's gonna be really difficult to not end up with, like, fucking this standard is terrible. I do not have my work cut out for me. It's taking a lot of fucking work.
All the while, the Glassworm malware is using this to steal GitHub access tokens to push copies of itself into Python repositories, right? So we kind of talked about like the JavaScript side of this, using this loop, right, to like decode itself. Well, this same process of just doing an eval on data that you decode that can't render in a text editor can apply to Python too, right? The attack targets Python projects, including Django apps, machine learning research code, Streamlit downloads, and PyPy packages by appending obfuscated code to files like setup, main, and app. Anyone who runs pip install from a compromised repo or clones and executes the code will trigger the malware. What? The decrypted payload is executed entirely in memory and never written to disk via eval on Mac or Linux or in a VMscript sandbox on other platforms. A persistence lock is written to init JSON with the current timestamp, and the malware will not re-execute within a 48-hour window on the same machine.
So is JSON also vulnerable? Not just JavaScript? Because usually they're like, oh, JSON, yeah, way better than JavaScript. Yeah, it can't be. It's not susceptible like JavaScript because it's JSON. Or it's just like, it's just saying it's gonna delay it, the trigger. I don't know, whatever.
Guys, this is like advanced malware, like C2 tactics kind of stuff. It's a little crazy, actually. So 2 packages in particular have been found: a React Native international phone number and React Native country select. The rogue versions detected on March 16th have been found to contain a pre-install hook that invokes obfuscated JavaScript to initiate a series of actions to skip Russian victims. Interesting. By inspecting environment variables and operating system time zone, and reaches out to a hard-coded Solana wallet, also linked to Glassworm to extract the payload URL and deliver platform-specific malware. What could this possibly be? I don't know, man. So like, if you're in this world where you think I guess if you're a developer of any language, maybe do a few things. First of all, check to see if you have this init JSON on your computer. Also, like, I think the recommendation from Ars Technica is you have to like inspect the packages before putting them in the projects. That's not happening. If you're seeing this weird, like, take this data and subtract in your code, I'm sure there are ways we can find this via signature. Also, if you're gonna be downloading packages from OpenVSX, if you see a non-authorized publisher and a repo that has like maybe like 4 or 5 stars, or like stars that are not proportional to the download amount, maybe don't install that. That being said, I think like downloads and ratings together is probably also not indicative of like trust, right? It probably is, I don't know, I've never done this before, I don't know, but it probably is easy to spoof a rating or to spoof download numbers. I'm not really sure, but in either case, just watch what you're downloading. Maybe you could audit the packages before you use them. It's not the easiest thing to do, but it is an easy way to make sure you don't get hacked. I don't know. So what do? I don't know. No, I'm just kidding. There are probably like 2 things you should do. One, have like active measures, right, where you have maybe scripts set up where you're checking for patterns like this. I'm sure you can find.
Or you're like, just never use a web browser again. Or wait till like a new, way faster JavaScript engine comes out that's not like vulnerable, like that crap. The V8 engine is absolute garbage. So I don't subscribe, don't do whatever you want. Like, you could go suck a dick. I don't care. Seriously, do what you want. Dick jokes, they never get old.
8, and you add each of the 2 previous numbers to get the next one. I love that this simple mathematical idea is able to describe lots of natural phenomena, such as the spacing of seeds on a sunflower, and the number of spirals left and right on that same sunflower is often a Fibonacci number. For people who have heard of the Fibonacci sequence, they often believe 2 things about them. One is that they have some kind of connection to human aesthetics, and 2 is that they're named after the person who discovered them. But both of these facts are wrong. When you type the word Fibonacci into a search engine, you can come face to face with some of the worst pseudoscience slop you'll ever find. Here are some examples. This one I don't think has a single correct fact in it, but it is playing off the sense that people find the word Fibonacci to be mysterious. And this one here is claiming that your life will be forever changed if only you learn about Fibonacci. And maybe that's true if it inspires within you a lifelong love of learning mathematics, but I don't think that's what they're referring to. This one is claiming that the Fibonacci sequence is literally everywhere, and that's not true either. It's in a lot less places than people claim. It does feature most prominently in the world of phyllotaxis, which is the arrangement of parts of a plant and other things that have the same sort of structural optimization. But most of the examples here do not fall under that category, and it doesn't prove that the entire universe is interconnected. I called this Fibonacci slop, and I'm using the word slop here to refer not just to things that are AI generated, although a lot of this is exactly that, but also to ideas that are rebaked over and over again and lose a little bit of truth every time. So what is it about this simple list of numbers that has such a power over our imagination, and where does the truth lie? Well, I think it starts with going back to Fibonacci himself. I have here Fibonacci's Liber Abaci, which is his original manuscript from 1202, where he first describes the Fibonacci numbers. It is this book that is the reason the Fibonacci numbers are named after him, even though his real name wasn't Fibonacci, it was Leonardo of Pisa. For all the fame that the Fibonacci numbers have, I've never actually seen someone going through this book before, and I was curious to know what Fibonacci himself actually said about these numbers. Did he ever make any of these wild claims? Did he ever say that this sequence was some kind of connection to nature or God or anything else? What was Fibonacci actually doing that led to him discovering these numbers? As I was researching this book, I found that it was a very influential textbook and had a huge impact on the history of mathematics. In a way, you can thank this book for the fact that math class today looks the way it does. Firstly, he introduces the Hindu-Arabic number system to the Western world. This wasn't the first book introducing them, but it was the first one aimed at workers and tradespeople. The other books had been aimed solely at academics. This was teaching a general public this concept of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, and he was teaching it to people who had previously been using Roman numerals. The book title is Latin for Book of Calculation, and its second major influence on modern math class becomes obvious once you start to read it. It's really hundreds of word problems used as examples to teach math concepts. To drill down this new idea of the number and place value system, Fibonacci comes up with every conceivable example that might be relevant to the merchants and traders who might be reading this book. Some of them are bordering on a little absurd, and so it feels like the original source of problems that are like, Jimmy bought 45 watermelons from the store. How much change does he get? He's made everything very real world and is teaching theoretical ideas through these somewhat relatable example problems. So let's take a quick browse through the book. In the prologue, Fibonacci talks about how, as a teenager, he left Italy to join his father in Algeria in North Africa because his father was working there as a merchant and customs official. There he encountered the Hindu-Arabic numeral system, calling it the 9 Indian figures, which was taught to him through Arab scholars and merchants. Chapter 1 starts with explaining how you can put these digits together to form numbers using the place value system. This is all new. The people who would be reading this book would be using Roman numerals up until this point. And it's not just a new way of representing numbers that Fibonacci is introducing here. By using this system that we are all familiar with today, you actually unlock, I guess, the powers of arithmetic, of being able to add, subtract, and multiply numbers in a more visual way that you can keep track of on paper. Previous to this, the traders would be using one of 2 methods to carry out their calculations. The first is finger arithmetic, so they would actually hold the values on their fingers using the method described actually in one of the first pages of the book, or they would use a mechanical abacus. So we see a bit of a conversion example here from Roman numerals to the new system. Once you've got a grip on how these numbers work, he shows how to multiply them, basically gives some multiplication tables, the kind that, we would still memorize in school today, and the same for division and addition and subtraction. Fibonacci is explaining step by step what digits to write where and what to do with them. A modern-day textbook would probably just give a general formula and maybe an example or 2, and then you can simply plug numbers into that formula. But that kind of algebraic notation was still several centuries away. Instead, Fibonacci relies on giving as many concrete examples as possible, each using slightly different numbers. It's more like a mathematical cookbook. You'll notice that fractional numbers are written kind of strangely. He's written the fraction part before the whole number, and these numbers would be built up from right to left. Each new fraction to the left represents that part of what is to the right. Might sound a bit confusing, but it's like if we were to write the decimal 1.729 out like this, where the 1 is on the right, then 7/10, then 2/10 of a tenth, or 2/100, then 9/10 of a tenth of a tenth, or 9/1000. Here's an example problem about buying 100 hides. If 100 hides are worth this amount of pounds, then how much are 32 hides worth? Here's another example of buying large quantities of things. We're buying now 100 canes of cloth or a ton of peas and cheese. Looking through here actually gives you a nice sense of what medieval life was like, or at least the items that they had and wanted to trade. There's pepper or silver and goat skins. And then we get into trades, like trading pepper for cinnamon, or even for saffron. I'm sure we still have problems like this today in math class, and also a tricky problem on a man who buys 30 birds of 3 kinds for 30 denarii. The real juice of this book starts at chapter 12. There are some quite interesting and also funny problems in this chapter. On finding the life of a young man, or on the lion who was in a pit, on 2 ants, one of which follows the other, on 2 ships that meet, and then we have this seemingly absurd question on a butt that has 4 holes, one above the other. I was very confused at first, but it does seem that a butt is something that stores barrels, because on the next page they're talking about emptying barrels, and Googling it, it looks like it was a medieval unit for a measure of wine. And so a buttload of wine is about 475 litres. There's a lot of figuring out how to share things between people, including this problem about sharing denarii between 4 men, which is apparently an unsolvable problem. And I just really love some of these titles. The man who hastened to Constantinople to sell 3 pearls. There are a lot of questions about what to do if you and your whole squad find a purse together. We've got a purse found by 3 men, a purse found by 4 men, a purse found by 5 men. In fact, the finding of a purse by multiple people is described in such excruciating detail with so many examples that one is led to believe this is some kind of common occurrence, or it's just symbolic on how to share things in general. This one is truly incomprehensible. On him who went into the pleasure garden to collect apples. You can pause this one if you want to try and figure it out. This one sounds like some kind of comedy routine on 2 men with fish and the customs agent. There was no English translation of this book for 800 years, which is kind of crazy given how influential it was. The reason might just be that there wasn't a lot of demand to read it, even from mathematicians. Because apart from some of these headings, the actual meat of this book is really hard to read and kind of boring because we already know how to do, calculations with numbers, and we can teach people how to do these things now with less confusing ways. It shows that math is really cultural, even if we don't think it is, because our upbringing and our education makes this book hard for us to read, even though it's the same familiar stuff that we would learn in school. What I've been showing you here is the English translation by Lawrence Sigler. And at the start, we actually see that he passed away before this book was published. There is a really interesting story even behind that. Lawrence knew that a translation of this book should exist, so he taught himself Latin to do it, using only a small copy of a compact Latin dictionary. He started with another of Fibonacci's books called the Quadratorum, and then moved on to this Liber Abaci. However, he was diagnosed with cancer while working on it and had to race to finish. He completed his translation in 1995, but his publisher knew nothing about his ill health and kind of just stalled on the book and didn't publish it. They were waiting to have more resources or to be in a better position to publish it. Unfortunately, it was still just sitting with them when Lawrence Sigler died. The hero of the story really then became Lawrence's wife, Judith Sigler. She kind of took over the project, and because the publisher didn't know that Lawrence had even been sick, Judith actually didn't tell them. She pretended to be Lawrence, replying to emails from the publisher and asking them when they're going to publish it. She was worried that if they knew he had died, the project might be scrapped. There was another challenge. The book needed to be typeset, and the mathematical formulas and columns and tables needed to be put into LaTeX, which if you're a math or science student, you'd be familiar with. It's like learning a whole nother language again just to type up your document. Judith then had to teach herself LaTeX and is the one who formatted all of these tables throughout the book. She became essentially another layer of translation in this story, yet another translator of Liber Abaci. Eventually they published with Springer, who weren't the same publisher that held up the project in the first place. And in 2002, 800 years after Fibonacci wrote it, this English translation was finally published. Right, so we've been through all this, and yet there's no sign of the so-called Fibonacci numbers. No golden ratio or spiritual claims. In fact, everything has been very rooted in the practical. So let's go to page 404. It's in chapter 12. And this is where we will find the mention of the numbers that will go on to be called the Fibonacci numbers. It's titled, How Many Pairs of Rabbits Are Created by One Pair in 1 Year? It's a population puzzle. You start with 1 pair of rabbits, 1 male and 1 female. The rabbits take 1 month to mature. Once mature, each pair produces a new pair every month, which are again 1 male and 1 female. And none of the rabbits ever die. So in the first month, there's just the original pair. In the second month, that pair matures, but there's still only 1 pair. In the third month, the mature pair produces a new pair, so now there are 2. In the fourth month, the original pair produces again, and the younger pair matures, giving 3 pairs. In the 5th month, the 2 mature pairs each produce a new pair, bringing the total to 5, then 8, then 13, and so on. We have 377 by the end of the year. Each month's total is simply the number of pairs from the previous month plus the number from the month before that. And Fibonacci doesn't say much more about it after that. It's just one practical example that relates to rabbit population growth. It was included because it's an easy problem for practicing how to use this new number system. Turns out its author's greatest fame would rest on this one little problem. So I mentioned at the start that one of the myths that people believe about the Fibonacci numbers is that they are named after their discoverer. They are named the Fibonacci numbers because of the book we just looked at, but Fibonacci, or Leonardo of Pisa, did not actually discover them. He was merely the first to popularize them for a Western audience. In Fibonacci's book, he was bringing back maths he had learned from the Arab world and indirectly from Indian mathematicians who had been there. So if anyone discovered the Fibonacci numbers, it was the Indians. One of their earliest appearances was actually in a Sanskrit text on poetic meter. This is attributed to Pingala, somewhere around 400 BCE. This wasn't about rabbits or spirals, instead it was about poetry. The Indian scholars analyzed long and short syllables in the poetry and asked how many different possible rhythmic patterns there were in a given length of text, so it was really a combinatorics problem. In Sanskrit poetry, there are these units, kind of like syllables, and they're called mora. You can have one that's light, and it's denoted by this vertical line, and that takes up 1 unit. Or you can have a heavy syllable that's denoted by this S, and it takes up essentially 2 units. Then, if you ask how many different ways there are to assemble a certain line of poetry which has a set length or a set mora, then these are the options that you get. There's only one way to have 1 syllable, and that's with that light one. But there's 2 ways to have 2 morae, which are the heavy syllable or 2 of the light ones. There's 3 ways to have 3 morae. There's 1, 2, 3, 4, 5 ways to have 4. There's 8 ways to have 5. And the next table lists the 13 ways that you